Hello students, in this video we are going to solve this very important exercise. XOT and XOZ are two adjacent supplementary angles such that XOT equals 50 degrees. Here we have two adjacent supplementary angles and the measure of one of the angles is given. So first, draw the figure, then calculate x, o, z. So let's draw a figure first. Let's draw first an angle measuring 50 degrees of vertex O. Using our protractor, we draw an angle measuring 50 degrees. Now I don't name the angles yet. Why? We know already that two adjacent supplementary angles, they form together a straight angle. So if I extend this side, I will obtain these two adjacent supplementary angles. Now, what should I name each of these three sides? First, you need to find the common side of these two angles. Let's find the common side. Let's check which repeated letters we have in both names of these two angles. We notice that X and X is repeated, O and O is repeated. So OX is the common side of these two angles, XOT and XOZ. And we know that in two adjacent supplementary angles, the common side should be in the middle, in between the two adjacent angles. So this is the common side. We name it OX. So here, although the name of this angle is XOT, if we name this side OX, our figure will be wrong. That's why we need to find the common side before naming the angles. Angle XOT equals 50 degrees, so OT is in fact this side, and the other side is OZ. And here we have two adjacent supplementary angles, XOT and XOZ. Then calculate XOZ. We need to calculate this angle XOZ. Solution. We know that these two angles XOZ and XOT are adjacent supplementary angles. It means their sum is 180 degrees. So XOZ is the supplement of XOT. So we do 180 minus 50 degrees to find XOZ. And 180 degrees is the angle TOZ. So we do TOZ minus XOT. XOZ equals TOZ minus XOT. Why? What gave me the right to write this equation? Supplementary angles effect. We use the supplementary angles property. The fact that their sum is 180 degrees equals 180 degrees minus 50 degrees equals 130 degrees. Now I know the measure of XOZ. I can write it on the figure in case I want to use it later on. Question B, draw bisectors OU and OV of the angles XOT and XOZ respectively. When we say respectively, it means in this order, OU is the bisector of XOT and OV is the bisector of XOZ. Question B, we can also say that OU bisects angle XOT and OV bisects angle XOZ. So OU bisects angle XOT and OV bisects angle XOZ. Let's draw these two bisectors. So before we continue, I will show you the steps to follow to draw these two semilines. To draw the bisector of an angle, we can use two methods. Either use our protractor or use our compass. Here, since the measure of these two angles is given, using our protractor is easy, but I will show you both methods. So first, to draw the bisector of XOT, we need to find the half of XOT. Half of 50 degrees is 25 degrees. I bring my protractor, I put the zero line on OT, center on O, I count from 0 till 25, I place a point above the dash of 25. Then using my ruler, I draw a semi-line starting from O passing through this point, and this semi-line, we name it OU. It's the bisector of angle XOT. Now let's draw OV bisector of XOZ. To draw the bisector of XOZ, I place the 0 of my protractor on OX. I count from 0 till where? Well, half of 130 is 65 degrees, so I count from 0 till 65. I place a point above the dash of 65, then I draw the bisector. Or, if you want also, you can place the 0 of the protractor on OZ. Then you start counting from the 0 to the left until you reach 65 degrees. So you can do one of these two methods. Then I draw semi-line starting from O passing to this point, and I name this semi-line OV bisector of angle XOZ. Now let's use our compass, second method. I put the needle on O to draw the bisector of XOT. I open my compass as much as I want. I draw an arc that cuts the first side OT of XOT, and another arc, the same radius, cutting OX. Then I put the needle on this point of intersection of the arc and OT. I draw an arc in this area here. I put the needle on this point of intersection of the arc and OX. I draw a second arc that cuts the first arc. These two arcs will intersect at this point. Then I draw a line starting from O passing through the intersection of the two arcs, and you obtain OU bisector of XOT. Now to draw OV bisector of XOZ, I do same steps. Here you don't have to use the same radius. You can open your compass as much as you want. First I draw an arc cutting OX, so the sides of XOZ are OX and OZ. Then I draw an arc that cuts OZ, of course with same radius. Then I put my needle on the intersection of the arc and OX. I draw an arc here in this area. I put my needle on this intersection of the second arc with OZ, and I draw a second arc. Here, if they don't meet, I extend them until they meet. So here, if they don't meet, don't panic. You extend them again until they do. Then you draw the bisector OV of angle XOZ. Now let's draw again on this figure OU and OV bisectors of XOT and XOZ respectively. Of course, when you draw the bisectors of these two angles, you can use the instrument that you want, a protractor or compass. It depends which instrument you feel more comfortable using. Now we put check here because this question is done on the figure. Now question C, calculate the angles UOX and XOV. Let's start with UOX. Question C, question mark here. How are we going to calculate angle UOX? Of course, we cannot measure it. Here we know already that angle XOT is 50 degrees and the semi-line OU is the bisector of XOT. So of course we can deduce the measure of XOU. It's in fact the half of XOT. It's half 50 degrees because OU is the bisector of XOT. It divides XOT into two equal adjacent angles. So UOX equals XOT divided by 2 or TOX divided by 2, same angle. And what is the reason? What gave me the right to write this division equation? Angle bisector effect equals 50 degrees divided by 2 equals 25 degrees. So now we know the measure of XOU. We can write it on the figure in case we need it later on. Now let's calculate angle XOV, question mark. We know that OV is the bisector of angle XOZ. So OV divides XOZ into two equal adjacent angles, XOV and VOZ. And XOV is half of 130 degrees. it's 65 degrees, so it's half of the angle XOZ. So XOV equals XOZ divided by 2. What is the reason? Same reason, angle bisector effect equals 130 degrees divided by 2 equals 65 degrees. Now we know the measure of XOV. We can write it on the figure. Last question, D, deduce that the angle UOV is right. It means deduce that it's a right angle. This is angle UOV. Is it a right angle? Question mark. How are we going to prove that angle UOV is a right angle? We need to prove that it's equal to 90 degrees. Can we do it? Let's see. We notice here that angle UOV is formed of these two angles of measure 25 degrees and 65 degrees. It means it's the sum of the two angles UOX and XOV. If we add them, we obtain 25 degrees plus 65 degrees equals 90 degrees. So we used angle addition to calculate UOV. So question C, UOV is equal to UOX plus XOV. What is the reason? Angle addition equals 25 degrees plus 65 degrees equals 90 degrees. And as a result, the angle UOV is a right angle. Result, UOV is a right angle. This is the end of our video. Thank you for watching.